video we're going to demonstrate our software Optimal, and we're going to focus on how we can use it to reduce construction costs and design time. The example I'm going to use is a 5-kilometer section of the file that was provided to me, and we're just going to start around station 99 kilometer. The provided example was just a horizontal alignment. I've gone through and clicked in a vertical alignment, and that's just so we can have an apples to apples comparison between a by hand design versus a optimized design. Now here I've got our ground types table open up, and this is going to be used to really drive the optimization. So each material type we have a handling cost associated with it, and then we've also got our movement costs. So movement costs, we've got free haul, end haul, and overhaul, and we've got specific unit rates that we can assign for those. Now I'm going to set up our vertical options. So I'm going to add things like our pit spoil sites, control points, etc. I'm going to do this in the by hand design just so we make sure everything's the same. So that's just an apples to apples comparison. And yeah, here I'm adding a control point at the start and end, so the road ties in, the section of road we're handling ties in with the rest well. And I'm also going to go through and add a few spoil sites. So here I've just identified a few locations by eye that look flatter than the surrounding area where I think we can store some extra material. So with these we can add in a site prep cost. So if we have a bunch of potential spoil locations along the length of our road, it obviously costs to mow equipment and prep the site. So if it makes sense to eat a longer haul and not open up a given pitch or spoil site, the software is going to figure that out for you as well. Now here, I'm not going to implement any of these. I think we can leave it fairly unconstrained, but we can add things like full bench sections. We can control the direction of material movement if we'd like, add a minimum fill for section, minimum cut value, etc. Yeah, so just going to look at the cost for that. So we've got a cost of 10.2 million. And I'm just going to go through and copy that and create an alignment that we're going to actually optimize. So the by hand design was 10.2 million. Now we're going to use those same settings that we've assigned and actually do the optimization. And it's doing its sampling along the length of a road. Now it's doing the optimization itself. And here we are, optimized solution found. So we went from 10.2 down to 6.5 million. And we can do a side-by-side comparison of those numbers and see how they relate to one another. So now, with that previous example, we've got curves butted up right against each other. So I'm just going to change this to do a variable curves and tangents. So it's going to be a little more constrained. We're going to force there to be tangents between our curves. And it'll take a little longer to solve, but the results are an alignment that's only slightly more to build and a little smoother, fewer curves. There we are. We can see we have gaps between those vertical curves now. So when the software is calculating its material movements for costing, it's using something more complex than just a conventional mass haul diagram. It's using our OptiHaul technology. And with that, we can see that we've got arrows going in both directions, and that's representing material movement in multiple directions at the same spot. The reason for that in this case is what was assigned for our subgrade material type, and with this example, the fill is set as SR for solid rock. So we're using the excavated solid rock to construct our the fill portion of our subgrade, and then the extra material is being moved around, and in this case it's being moved to the spoil sites. And in this case that is just a function of how the design's set up. If that's not actually the case, you can adjust the assigned by range parameters, and the software will account for it accordingly. Another big benefit of using the vertical optimizer is to use it to compare different options. So here I'm just going to duplicate my horizontal alignment one. I'm going to delete a section out of it and see if we can do better. So this, I'm not covering anything new for content. I'm just going to rough in a quick new horizontal alignment, make sure it works in the vertical, and going to re-optimize it. Yeah, so oftentimes when you're comparing different options, it's really easy to do a great job designing one of those options and a not so great job designing the other. So then if you're comparing them, doing a detailed comparison, taking into account material movement and volumes, it's not an apples to apples comparison. So with this we can standardize the design effort, also ensure that the options that we are comparing are the least possible cost. So we've just about got this tidied up, and let's do a couple more minor adjustments, and let's optimize. And with that, we've reduced our cost to 5.7 million. So, just another tool in the toolbox. Thanks.